Okay, so we're currently doing the EPI exercises, and today we're going to do the exercise 4.5 multiply. Okay, cool. So the exercise is saying basically just let's say that we are in the situation that we have a low energy CPO that doesn't have a multiplication operator or addition or subtraction, and what we need to do is just implement this operator on our own, and what we can use is only bitwise operators, assignment, and equality checks. So that's great. So let's say that we have integer 3 times 5, which is 15, right? So what we need to do is just, let's say that we represent this number as in binary. So 1, 2, 4, 8. And we have number 3, 5, and then result is 15. And for the numbers 3, so we have 1, 2, 1, 1. The rest are zeros, and for 5 is just 1, 4, and 1, 1. And we get, and that 15 is basically just all ones. Okay. So yeah, what we will need to do is just implement the multiplication operator. And what we'll be doing is that we'll be shifting operators by 1. And yeah. Cool. So the trick here is that let's say that we are shifting this guy by 1 to the left, so we are removing 1, and if it's 1 we just add the rest of the number, right? And then on each iteration we let's say the first one number we remove the last bit, and for this guy we just double it by shifting the number to the left, right? Okay, and for addition it will be quite similar. Okay. So let's talk about time space complexity for this one. So for addition it's O of n, but because we're doing a lot of additions to the multiplication, it's actually O of n squared for multiplication, and for space it's O of 1. We don't use any additional space. Cool. So let's try to implement this in code. So we have two numbers which we need to multiply. We will store the temporary result in the res variable. So let's say it's 0. And then while a is not 0, every iteration we will check the last bit of a. So if a and 1, so if the last bit is 1, what we do is we just add b to the rest variable. And on each iteration for each bit, what we'll do is we will just remove the last bit from a, and we will double b. Yeah. And when the a is 0, we just return a result. Cool. So now we have this a function, which is helper. And yeah, we can implement this as well. So we have an add function. So we can say that while while b, if b is 0, we just return a, which is correct. So if we need to store the carry, of course, which is just a and b. So if those bits have, let's say, 1 1, it will be stored in carry, and the results for a, we just XOR the b, right? And we need to store the carry into b, right? Back. But this is not enough because carry goes 1 to the left. We need to shift it by 1. Okay. And once the b, which is basically a carry, is 0, we just return a. Okay. So let's implement this in code and run the tests. So for the multiplications, I can say result is 1, 0. So while a, and we check if a is 0, and if it is, we just add b to the results, and on each step we do the shifting. After we're all done, we just return a result. So b is carry, shifted by 1, and once the carry is 0, we just return a, right? Let's just quickly check if everything adds up. So for multiplication, we have result 0, while a is not 0, we just check the last bit. If it is 1, we just add it to the b, and we're doing the shifting. Okay, cool. Let's run the tests. And they don't pass. Name error. Nice, it's okay. Okay, the test passed. So that's all for today. Until next time. Bye.